All righty, up and running. Wednesday, 2 more days before the midterm. You have requested some rational functions, some trig equations, some identities, and sketching a cubic, putting it in graphing form. So I will move this. Hopefully that's centered for you to take a screenshot. Go ahead, take your screenshot. I'm going to go to the other side of the room, take them one at a time, try to layer some contextual understanding, deepen our understanding of the mechanics and what's going on numerically. And let's have at it. All right, so I'm going to unplug. I think I got enough juice in the battery, and I'm not worried about having it die. All right, so we'll put this on this table. We'll bring this nicely erased board over, and we will talk about graphing. F of x equals 2x plus 6. 2x plus 6 tells me that unless it divides out of the problem, -3 is a root. So let's make that -3. And now that's 3 units of change. 5x plus 7. The denominator tells me that -7/5, which is about here, is undefined. The closer I get to -7/5, the smaller the denominator, the more it's going to fit into the numerator, positive and negative times. What else do I see? I see that 2/5 is an asymptote. And I want to look at that first and find out why. So the question then becomes, this is end behavior. In other words, as x's go to infinity, what's the limit? As x goes to infinity of this fraction, 2x plus 6 over 5x plus 7. Let's do a little analysis. Let's put the number 1 in. 8 over 12. Let's put 10 in. 26 over 57. Let's put 100 in. 206 over 507. I'm starting to see a pattern. Are you? Let's put 1,000 in. 2006 over 5007. I wonder what this ratio is heading towards. Yep. Now, anytime the exponents are the same, that's going to happen. And it didn't matter if I did negatives, right? Because both would have been negative. Same thing's happening over here. There are no more x-intercepts over here. There's only one. Looks to me like that's got to happen. Of course, you can always pick a number near -7/5. Why don't we pick -2? Let's put -2 in. -4 plus 6 is -4 plus 6 is +2. Almost wrote a negative. And -10 plus 7, -3. All right, I think we're in the right vicinity. All right, but you can check more numbers. You could play with more numbers. I mean, we kind of already checked these out, right? And there's no crossing the x-axis over here. There is only one crossing, one sign change. So there's a sign change here as well because it's to the first power. So then the question is, what do you get when you put a number like -1 in? -1 is here, right? What do you get? I'm suggesting you're going to get something that looks like that. You're going to get some kind of positive number here. So let's put -1 in. I get 4. I get 2. All right, so if this is 2/5, I don't know where 2 is here. We got to get Claire to graph these. Her graphs are much better. All right, but I'm just looking at it conceptually. There's your graph. Well, you could probably label the y-intercept, right? It should be less than 2. Oh yeah, it's 6/7. 0.6/7. Well, that's what you're trying to learn how to do. All right, so let's look at the next problem. G of x. We get a nice board here. G of x. A different fraction. Numerator, x minus 1. Well, unless that divides out, I immediately know that I have a root at 1 over x squared minus x minus 6. Oh, is it okay if I factor that? X minus 3, x plus 2, and I hope I didn't make a mistake, because if I did, everything's wrong. Positive 3, that would be about over here, I guess. Negative 2. End behavior, 0. Asymptote. Asymptote. How do I know that? Because I'm answering the question. What's the limit? As x goes to infinity, again, end behavior of the fraction. Can I just write, now I'll put it in here. X minus 1 over x minus 3 times x plus 2. Let's start with a 1. And do the same thing we did before. Oh, we know that one's 0. So let's go right to 10. Well, that's 9 in the numerator. Denominator, 6 times 11, 66. Pretty small fraction. Let's go to 100. That's 99 over, oh my God, 97 times 102. Can I just write it as 97 times 102? I mean, these basically cancel. I'm pretty close to 1 over 102. I think I'm going to 0. I don't even want to think about 1,000. 1,000 gets me 999 over. I'm just going to put the parentheses here and you figure it out. 1,000 minus 3, 997. I think there's a pattern here. And 1,002. I think there's a pattern there too. I think we could probably write a whole bunch of these every time we increase by 10. I got a feeling that fraction smaller than this one. This fraction here is smaller than that. I think I'm going to 0. And the question is, there's no x-intercepts over here, so it's either got to be that or it's got to be that. I think I'll do the one here because I have a feeling that if I pick numbers bigger than 3, that's positive, that's positive, and that's positive, and that's positive. In fact, we already knew it, so why didn't you yell at me? Because we already had that information. And I get a sign change. Probably looks like that because I get a sign change at 1, too. Remember, this is the first. You're getting sign changes. Positive, negative, positive, negative. But you might want to verify that. You might want to put a 0 in and see if you have a positive y-intercept. And if we do, it's 1/6. Going back to the original equation, you have it in front of you. 0, 1/6. So I should have been, down in this vicinity. So this is really, really much lower than where I drew it. And we might want to check something like -1. Does it give me a positive number up here? Let's put -1 in. Well, that's -2 over -4. -1 makes +1. I get a half. Well, it's positive, right? So really, this part of the graph really looked more like that, right? I mean, we can do a better job drawing, but it's just getting the general information in front of us. Now, I should do a slant asymptote, but I don't think I will. I think we'll keep it right there and worry about slant asymptotes after the midterm. All right, so I hope that helps. And now we're going to do the trig equation. I'll get a nice board here. And we're only going to solve these trig equations for 1 revolution of radians, only angles between 0 and 360. Because the argument of the function, and the argument of this function, I will point out to you. I think I put x. I almost drew theta there. secant squared x, that's the argument of the function. And that argument is an angle. Okay, so minus 6 equals negative 4. All right, so secant squared x is equal to 2 over 1. Now, why am I writing it 2 over 1? Because secant squared x is 1 over cosine squared x, and that's equal to 2 over 1. I think I can take the reciprocals. I think 1/2 is equal to 4 over 8, and if I flip both, I think 2 over 1 is 8 over 4. I'm going to flip both, and if I do, I get cosine squared x equals 1/2. We did that in class. Cosine x is equal to plus or minus the square root of 2 over 2, right? 0.71. Let's just look at 0.7. 0.7 squared is 0.49. 0.7 squared is 0.49. And so that's going to equal 1. I mean, that's almost a half and a half, right? Putting it to 0.71 gets it a little closer, but we're just doing some estimating here. So what is this? Well, that's pretty much a half. So what is that length? Well, that's the square root of a half. Hopefully that makes some numerical sense. So this becomes square root of 1 over square root of 2, plus minus, of course. That becomes 1 over root 2 when you rationalize root 2, just as a reminder of where that's coming from. All right, so this is width. Your widths are plus or minus root 2 over 2. This is an angle. Okay, where are my widths going to be root 2 over 2? 45 degrees. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. All of these have widths of 0.71, 0.71 negative, 0.71 negative, positive 0.71, 45 degree angles. So pi over 4, 3, all the odds. That's a nice way to remember it. All the odds put you in the middle of those quadrants. And you solve the trig equation. Let's do another trig equation. All right, let's look at sine squared x equals, which one should we, I put 2 up there. I'm only going to do one of them because they're both basically the same. So let's do 2 sine squared x plus 3 sine x plus 1 equals 0. All right, let's just do that one. All right, it's basically the same as the other one. So I'm hoping that you think of this as 2h squared plus 3h plus 1 equals 0. Solve that first. All right, so what do we got? We got a 2h and an h. We got a 1 and a 1. No, that's easy enough. Plus 1 plus 1. So what do we got? We got our heights could equal minus 1/2 or negative 1. So you go to the circle. I know that height's 0. I know that height's 1. I know that height's negative 1. I guess we found an angle, 270 degrees. I got to go 270 degrees to get to negative 1, and I hope that that makes sense with the sine function, right? There's 90 degrees, 180, there's 270. And there's a height of negative 1. That's the minimum. So one of your answers is an angle, right? And that angle could equal 270 degrees or 3 pi over 2. The other one could have been minus 1/2. Well, minus 1/2 is there and there, right? Now you got to draw your triangles. Good drawings get good answers. I hope you get a sense of what that angle is. That angle is 30 degrees, right? Because we got minus 1/2, minus 1/2. The more you work with the 30, 60, 90s, the more you'll recognize that. So 180 plus 30, 210 degrees. 360 minus 30, 330 degrees. And that's 7 chunks of 30. Pi over 6 is 30. And 330 is 11 chunks of 30 degrees. I guess I got to put that down there, right? My fault. 210 degrees, right? It takes me to there. 180 takes me halfway around, going another 30 takes me to there. That's 7 chunks of 30. 330 is 11 chunks of 30. And we just solved 2 equations. All right, so we did rational functions, we did a couple of trig equations. Now we're going to do just a quick cubic, 8x cubed plus 125. The pattern is start with the cube roots, build off of the cube roots. Okay, that's always positive. That's always positive. This one changes depending upon if you start with the sum, then that's a minus. If we had gone from a minus, everything is the same except this becomes a minus and this becomes a plus. So I think you asked for, I think maybe what you wrote about cubics was just the graphing. I don't remember. Kitty, you asked for that, I think. All right, so that was just a quick product. Maybe that's not what you needed, but I am going to do a graphing of a cubic in a minute. So now we got some identities. And I took these off the internet. I hope they're correct. There's nothing worse than copying something down that's wrong. Cotangent x equals 1. Now, when you get familiar with identities with a lot of practice, you don't always have to change everything into sine and cosine statements, but when you're first learning, it's a good idea. So secant, do you remember what that is? 1 over cosine x. And you're dividing by cosine x, which is really over 1, right? So when you multiply by the reciprocal, you're really dividing by cosine x twice or cosine squared x, but we'll come back to that, right? So I'm just going to divide by cosine x. That's another way of saying that. Tangent is sine x over cosine x, and we're going to be divided by cotangent, which is cosine x over sine x. All right, so we're going to do the multiplication by the reciprocals. 1 over cosine x times cosine x over 1, which I'm just going to write as cosine x, minus sine x over cosine x times sine x over cosine x, right? When you divide by, 5 divided by 3/4. I always thought of this as a kid as the seesaw. When the first person jumps, the second person flips. So that becomes 5 times 4 over 3, just as a reminder, just in case. All right, so I'm just multiplying by the reciprocal. That gives me 1 minus sine squared x over cosine squared x. All right, so we got to get a common denominator. So multiply everything by cosine squared x and then divide by cosine squared x. Gets me cosine squared x minus sine squared x over cosine squared x. Now this is where you start looking for hints. The number 1. Well, the only way I can get 1 is if this becomes cosine squared x over cosine squared x. It's the only way I can do it. So what am I going to do here? I'm going to subtract by Did I get myself in trouble here? I hope not, because I don't want to make the whole video over again. All right, so I'm going to play with this and then see if I did something crazy. So sine squared x is 1 minus cosine squared x. Minus and minus is plus, so this becomes 2 cosine squared x minus 1. So I'm going to go back and look at my work. Why didn't you yell at me? You should have yelled at me. Okay, talking to you. This should have been multiplying by the reciprocal, which is 1 over cosine x. Okay, so I got to start here. All right, didn't take too long to catch it. Oh my God, I'm tilting. Vertigo. All right, let me sit here so I can write so that you don't have to look at it with your head like that. So this is 1 over cosine squared x minus sine squared x over cosine squared x, which is equal to 1 minus sine squared x over cosine squared x, which is equal to cosine, can you see this? Yes. Cosine squared x over cosine squared x, and that indeed is 1. So it has been proved. Sorry about that up here, right? I'm talking to you, not thinking enough about what I was writing, all right? And I'm going to try to write this, learn to write this so that you're not looking at it sideways. So this line of work I'll write over. So this is 1 over cosine x times 1 over cosine x minus sine x over cosine x times sine x over cosine x. Then hopefully you can see that more clearly, the thought process. Okay? All right, brain's a little tired. I will try to be a little slow the pace down so I don't make those careless errors, but I got another video to make for the other crew, and I got some work to do at the house because we're moving. And anybody who's moved from a house to another house knows how much work it is. All right, so we're going to look at 1 plus cosine x. Let me see if that's straight across. That's a little better. Over sine x, and we're going to prove that that is the same as cosecant x plus, make sure I copy it right, cotangent x. All right, so which one do I want to work with? I'll work on this side, right? Because this is, I'm going to turn these into sine and cosine statements, so I think it makes sense to be over here. So that's 1 over sine x plus cosine x over sine x. Now I'm taking a little shortcut. I really should be putting these x's in parentheses because they're arguments, right? But taking some time here. So this is 1. Oh, I'm done. All right, sorry. I was expecting more. I'm done. Okay, I guess you couldn't see that. God almighty. I hope that didn't happen on every problem we've done. All right, so I renamed that as 1 over sine x. That is cosine x over sine x. Common denominator, added it up. I look to the left. We're done. All right, I'm going to put this into graphing form. I'm going to do what I know how to do. And you can listen on and maybe pick up a couple of things, hopefully. So y equals 2x cubed minus 18x squared. I got a canned problem here, so we can work with mostly integers, plus 4x minus 10. 4x minus 10 is that little snippet of the graph. The more you zoom in on it, the more it looks linear, and it's going to look like that. We talked about what? I want to find out where this thing goes. Oh, it starts to bend, but this brings it back. So I know this is going to look like that, and I know it's going to look like that over here. What's happening in the middle? I'm going to analyze right now. I want to see where it bends. The point of inflection, where my acceleration changes. You'll study that in calculus. And it turns out, geometrically, it's minus b over 3a. And that is actually the average of the roots. So you're reconfiguring a cube so that it has equal sides. And when that volume registers 0, it's changing the least quickly. It's having the smallest slope anywhere on one of those snippets. Now, the smallest slope might be a number that's negative, and all the other tangents to the curve are bigger. Okay, and if you want to understand what I'm talking about, you actually have to dive into the geometric implications that are in the YouTube video that I uploaded. It's there. All right, but I'm just going to do this more quickly. So minus b, this is b, ax cubed, bx squared, cx d. That's b. So 18 divided by 3 times 2 is 6. X value of 3. That's 10 units. 3 units is probably about there. So this thing is going to turn here. Now, I'm guessing, I don't know if I have roots, real roots or not. So I'm going to find out what goes with the 3. What goes with the 3, and then I'm going to find out the rate of change there. So when I put 3 in, I'm going to get 54. This number is always 3 times the size of that and opposite. I hope when you multiply, when you put a 3 in here, you get that. I'm assuming you do. Now, this isn't too bad. All right, so this thing, I don't know if it's crossing the x-axis or not. So I'm going to leave that. I'll show you how you can find out. Do I want to do it? I really don't want to do it. All right, so I'm not going to use an x-axis here, right? Because I'm just not going to find the roots. It takes a while. Could be a nasty number. All right, so when you add these, you always get twice that in the opposite. So that's going to be minus 108 when you add these two. It's always twice that in opposite. And then we're going to get add 2. So we actually are turning, this is a pretty big number. For this to start to counteract that, it's going to take a little bit of while. All right. So minus 106. This is minus 10. Minus 106 is way down. I can't go far enough. Right. It's way down there. All right. It's down here. But eventually it's going to come back up like that. Okay, so it's going to come back up, end behavior, going to positive infinity. Eventually this term wins out. What number takes care of that? Well, you could put positive 18 in. If you put positive 18 in, you can see that this term is twice that. So this is winning, and will continue to. So that's what your graph looks like. And so your point of inflection is at negative 106 for a y value. And it also occurred at x equals 3. Wow. Wow, that's really something. And this is where I'm going down steepest. I don't know if you can get a feel for that, but my y values are increasing, and eventually my y values are not changing much at all. No, I'm going to get a max. And then they start, my y values decrease faster till here, continue to decrease, but less quickly. So that has geometric significance. Now, what's the slope there? The slope at that instant actually is coming from c minus 3ah squared. C is 4, minus 3, a is 2, and h is 3. 3 squared is 9, so minus 50. So the slope here is minus 50. I'm going down. And how could you find that without calculus? Well, let's call this f of x. And I want to start having this conversation with you, so I guess it's starting right now. How could I estimate the rate of change? I could do f of 3.001 minus f of 3 over 3.001 minus 3. I just do a slope with a couple of places really close together. And I'm going to see I'm near negative 50. And the more zeros I put in here, the closer my calculation becomes. All right, so that's really important concept coming your way in a year or two. You heard it now. All right. There are ways to find the max and min without calculus. I encourage you to look at the YouTube video and find out how. But this gives me a little sense of what the graph looks like. Now, if I put this in graphing form, I actually use minus 50. You can check it out, see if I made any careless errors. You can use minus 50, x minus 3, minus 102, right? And that's the equation of that little snippet. We call it a tangent to the curve. And if you wanted to put this in graphing form, all you got to do, tack that in, and if you multiply this out, you actually get this. This is a linear function and a cubic. Now a cubic, just so you get a sense of what's going on here from a graphical standpoint, a cubic, this cubic really looks like that. And at 3, the rate of change here is 0. And if I intersect it with this linear function going down at 50 to 1. When I add the two rates up, I actually get this rate. And so therefore I get a graph that looks like this. That's what you're seeing. Okay, now these topics take time to understand. All right, your mathematical mind has to mature. All right, but it isn't going to get there unless we start talking about what's going on and why. So this is an entry level discussion, and there's a lot more going on here. And if you want to dive into it deeply, you got to look at the geometry and you got to think critically. But it will enhance your understanding of what you're looking at. So tomorrow we can talk about it, and tonight just see how you did on this. And I am now going to upload this and put it on your email. I'm going to email this to you. Ciao, ciao.